Let's talk about the prime numbers, what they are, where they're at, what they've been doing. Take a walk with me. Prime numbers, if you didn't know, are any number greater than 1 that are only divisible by themselves and 1, such as 3, 5, 7, 11, 13, 17, 19, 23, etc. Those numbers can only be divided cleanly by themselves and by 1. Now, the prime numbers are kind of weird because of this unique property. We can use them for things like encryption. To encrypt data, we often use prime numbers. But we still don't really know how the prime numbers are distributed. We don't know why they exist. We can't exactly locate them. We only know a number is prime by testing it. We look at the number 7 and we say, okay, can 7 be divided by 6? No, 5, 4, 3. It can only be divided by itself and 1, so it's prime. But when numbers get very, very, very large, this becomes increasingly difficult to test whether a number is prime. In fact, we don't really have a great way to do this for really large numbers. So knowing how these prime numbers would be distributed, we could locate every single one, but we don't know how. We don't even really know why they exist in the first place. Now, there are some very important mathematical theorems about prime numbers, one being the fundamental theorem of arithmetic, which states that every number has a prime factorization. So basically, you take a number like 20, that would be 2 times 10. 10 is 2 times 5. So if you do 2 times 2 times 5, you get 20. That's 20's prime factorization because 2 is a prime number and 5 is a prime number. And every single number has one of these. Positive numbers specifically have a prime factorization. And they're all unique. And we can use that property for a lot of other mathematical theorems. Another important theorem is Euclid's theorem of infinite primes, which says that there are an infinite number of prime numbers. As numbers get larger, the prime numbers get further and further apart on average, but we know for a fact that they continue. They don't just end at a certain point. They are infinite. However, we get into some interesting problems that are not yet solved that people have been working on for a long time, such as the twin prime conjecture, which states that there are an infinite number of twin primes, such that two prime numbers are 2 numbers apart, like 3 and 5, or 17 and 19. There's a conjecture that states there are an infinite number of those, and we can't yet prove it. We know it's probably true. We have a lot of evidence for this, but we can't prove it. Another huge problem that's adjacent to prime numbers is the Riemann hypothesis. This is known as a millennium problem, which actually has a $1 million cash prize, I believe, if you solve it. And if you solve the Riemann hypothesis, it will actually tell us how the prime numbers are distributed, or give us a really, really good idea. So that is another unsolved problem. And there are several huge unsolved problems that deal directly with prime numbers. So maybe if we get all of us looking at these prime numbers, looking at these conjectures and these theorems, maybe soon, who knows, maybe with the help of AI, we'll be able to uncover the distribution of primes and figure out why they exist and when they exist. Well, maybe one day.